Hi, I'm Ursula Sadiq, Product Manager with Autodesk Plant Solutions. In this video, we're going to use the AutoCAD Plant 3D Specs and Catalog editor to create a piping spec. When we first load the editor, we will see a welcome screen that lets us load recently used catalogs or specs, or to create new ones. We start by clicking Create for a new spec. Each project will have its own piping specs. We will add our spec to the sample project and name it A-6.4. We'll give it a description of line class A-6.4 and note that it is a demonstration spec because we won't be adding all the parts and details that you would need for a production spec. We will specify that we want to load the ASME piping catalog with the spec and click Create. The new spec is added to the project folder. Notice that there are three tabbed work areas in the spec and catalog editor. The Spec Editor tab has the spec sheet at the top and the catalog browser at the bottom. We have a branch table editor and a catalog editor. In this video, we will not discuss the catalog editor. Okay, let's add some pipe. We set the part category filter to pipe. There are 42 parts available in the catalog. Note the material and schedule are not set in the catalog. We will set these as we add the parts to the spec. The pipe ranges in size from 1/8 inch to 60 inches. We don't want to add all the sizes to the spec. We want our smaller pipe to have different schedule than our larger pipe. So for the smaller pipe, we set the pipe range from 1 inch to 1.5 inches. Set the property values to carbon steel, material code to A333, and set the schedule to XS for extra strong. There are now 3 sizes selected, and we can click Add to Spec to add the pipe to the spec sheet. Now for the larger pipe, we set the size range from 2 inches to 12 inches. We set the material code properties to API 5L and set the schedule to 20. We then select the pipe in the catalog browser and hit the Add to Spec button to add the pipe to the spec. Now we'll add some pipe fittings. Set the part category to fittings. We then set a size range of 1 inch to 1.5 inches again. We'll set a socket weld end type filter and a pressure class filter. Then we select T and elbows from the catalog. We set the material code to A350 and add the fittings to the spec. We'll now add some sockelets to the spec. We'll set the part category to OLED, and we'll set the size range to match our larger pipe, 2 inches to 12 inches. And we'll set the reducing range from 1 inch to 1.5 inches. Then filter on the short description of sockelet. Select our part and add it to the spec. Now we'll add the fittings for the larger pipe. We set the part category to fittings again and clear the reducing size ranges. We'll set the property override for material code to be A420. Set the end type to BV for beveled end. And select a 90-degree elbow, a T, and a reducing T, and add them to the spec. Next, we'll add some flanges. First, we set the part category to flanges, set the facing filter to raised face, and set the pressure class to 300 pounds. We can then select the weld neck flange, set the material code property to A707, and add the flange to the spec. We will need some bolts and gaskets for the flanges. So we'll set the part category to fasteners, filter the short description on flat gasket, and add 8-inch gaskets to the spec. For bolts, we'll set the short description to bolt sets, and pick both stud and lug bolts to add to the spec. Let's stop adding parts for a moment and take a look at the pipe in the spec sheet. Select the pipe and click Edit Parts. We added a range of sizes to the spec, but we don't want all the sizes. We can remove some odd sizes by checking Do Not Include for each size we do not want. Click Apply to remove the sizes and close the dialog. We have a size conflict in our bolts set. There's an icon to tell us the software does not know whether to use the lug bolts or the stud bolts. So here we'll tell it to use the lug bolts for the 2-inch and the 4-inch flanges, and for everything else, use the stud bolts. Finally, let's add some valves. Valves are in a different catalog, so first we'll open the ASME valve catalog, which loads in the catalog browser. We set our size range of 2 inches to 12 inches. Set the facing filter to raise face. Set our pressure class to 300. And look for the gate valves. We pick the solid wedge gate valve and add it to our spec. Let's also add a check valve to the same spec. Okay, now we can set up the branch table from the Branch Table Editor tab. The first thing we do in the branch table is create a legend. Each entry in the legend identifies which parts are needed for that type branch. Here we'll add a T, a reducing T, an OLET branch type, in this case a sockolet, and we'll add a pipe for a stub-in type branch. Using the legend symbols, we can populate the branch table. Click the T branch fitting, and then select the same size branch cells in the table. Press Ctrl as we click multiple cells. Click the Apply to Table button to assign the T. Next, we set the reducing T branches. Press Shift to help select large to small cells for the sockolet. And finally, for the rest of the branches, we will assign the stub-in. For the 8 by 12 inch branch, we'll add a stub-in to the reducing T. This will support a stub-in when the branch is not 90 degrees. This spec can now be used to route pipe in the project. As you can see, creating a piping spec with AutoCAD Plant 3D can be done quickly without sacrificing the detail that your spec requires. Thanks for watching.